DSA we have GFGPOD. It's a very basic question. It just deals with fundamentals of arrays and basic of trees. So see, what's the question? Before moving to question, let's have some motivation for the day. See, the motivation for today is like, every day we get up, get ready, eat food, watch little movies, series, cricket, and have our time, right? So like that, we should give time to DSA. Like every day, get up and solve DSA. If we solve DSA every single day, like rigorously, we will become one day champion in DSA. DSA should be like your breakfast. So if I want to tell in one line, it will be like DSA is breakfast for champions. So if you want to become champion, you should have breakfast, and for your breakfast, you should have your DSA in your breakfast. So today we have a wonderful question in our breakfast, which is check if an array is Max Heap. Okay, let's try to read the question we didn't understand by the heading. Let's move to the description. Given an array, determine whether it represents level order traversal. Offer valid max heap, return true if it does, otherwise return false. Okay, we understood we have given an array, we should return true or false. But what is this level order traversal? What is this max heap and all? Let's try to read example. What if we understand something? See, now from heading you got nothing, but from description you understood something. Now from example we will understand more. So like this we should approach a question. Okay, so you have given array which has some elements, it's returning true. Okay, the given array represents the following tree, like it represents in a tree format. Okay, each parent node is greater than or equal to its children, so the max heap property holds. Okay, let's first try to understand level order. See, what is level order? Let me explain you. See, level order is like Like a node is going level by level. First level 0, then level 1, and then level 2. And when it goes level by level, first this, second this, and third this. After going level by level, also it goes first from left to right. Always left to right. So it will be like 90, then 15, then 10, then 7, then 12, then 2. That is the meaning of level order. Now let's try to understand what do you mean by max heap. Max heap is a special type of binary tree where every parent node is greater than or equal to its children. Now you see, 90 is your node. 90 is your node. Okay, its children is 15 and 10. This is 15 is your left node and 10 is your right node. So 90 is greater than its left children and its right. Now we come to 15. 15 children are 7 and 12. Respectively, 7 is its left child and 12 is right. So 15 is greater than both its left and right. Now we come to 10. 10 is a node which is your parent, so this is your left, you don't have any right child, okay? And 10 is greater than your 2. So the max heap property is valid. So why it's returning true here? Because all the parent nodes are greater than or equal to its children. Now we understood the question. Let's move to some implementation. I'll just raise this. Let's take some. Huh. Now see. Parent should be greater than or equal to its left child and parent should be greater than or equal to its right child. Now let's discuss with the parent and child index. Let me explain this part. See, here is your parent. So this is your I equal to initially what? 0. Right. So for left, this is your left and this is your right. This is your left and this is your right and this is your left. Right, for left child the formula is what? 2 into I is what? Initially 0 plus 1. So the answer is 1. So here it comes 1. Indexing, I'm just telling about indexing. So it will be like 0, 1, this will be your 2, this will be 3, this will be 4, and this will be 5. So you understood how we got 1. Let's try to, let me take, let me explain for 2. So now 2 into I is what? It's this we are doing. I is what? 0. 0, but for right it is like plus 2. So this is equal to 2. Now see, we are taking this string. So this is the parent, I is 1. So how did we get 3? For left child 2 into I, which is now 1 plus 1. So equal to 3. Similarly, you understood for 4, it will be like 2 into 1 plus 2, which is 4. And for this, it will be 2 into 2 plus 1, left child. So 2 into 2 plus 1, which is 5. So you understood the indexing part, right? Okay, let me try to explain you the code now. Okay. So see, you have n equal to array dot length, you're finding array dot length, so your loop here, see, I equal to 0. It goes till which we need to find that. So I less than or equal to n minus 2 by 2. Why? See, if your left node is there, then only your right node will come. It's like that. It won't be like your right node will come first, then your left node will come. See, in this case, we don't have your right node, so it can be like 2 can you become your right node and that. No, first left, then right. So the loop will run till the left child node. So like 2 into I, which is less than n. This is actually less than n. So this minus comes plus will go there. So n minus 1. Then we are, oh, it's multiplying. So if it goes here, then divide. Now see, what's your n here? 1, 2, 3, 4, 5, 6. So 6 minus 1, which is 5. 5 by 2, which is 2.5. And so I here what here it will be 2, so the I the left the level it will go till I less than 2.5. But see, if I take n minus 2 by 2, which is n is what 6, 6 minus 2, which is 4, 4 by 2, 2. So 0, 1 and 2, and our nodes are like integer, right? So we are taking like we are just admitting what so that we get whole number. So we are going like till I less than or equal to n minus 2 by 2. Now I told like the parent node should be greater than or equal to left child. Now for left child we know the formula 2 into I plus 1. I explained also, it was coming correct, right? So if your array of I, if it's less than or less than, because it's telling equal to, so we should take less than 2 into I plus 1, then we are returning it has false. Similarly, like now see, this is your right side ka index 2 into I plus 2. That should be less than n. Why less than n? That should be less than n. And if it's less than n, then only the right node will exist. If the right node exists and array of I is less than the right value array, then return false because it should be greater than equal to, right? But see, left child will always exist, but right child has no surety, right? Here it was not. So we should write if it's less than n. And if it's less than the right child pointer, then return false, else return true. So this is the code logic. Let's try to write the logic. First we are finding array length. Okay, int n equal to array dot length. Now you're running the for loop for int I equal to 0, I less than or equal to n minus 2 by 2 I plus plus. If array of I is less than the left pointer 2 into I plus 1, then return false. Then I plus 1 plus 2. The right pointer if it's less than n means right node exists and array of I is less than or equal to not equal to less than array of 2 into I plus 2, then return false. The for loop ends and here it comes return true, and now we are running it. See, let's try to submit, and now all our test cases passed. So you understood this question? If you have any doubts, you can ask me in comment section, and all of you solve this question and submit it. And if anyone has any doubts, can ask me, because DS is breakfast for champions, and if you guys want to become champion, then you need to solve DSA every day.